an interesting malfunction that's well worth investigation. While I was back in Glasgow, I was browsing in shop windows and I saw a vapour producing device that is a disposable version that had a much higher capacity than normal. It was rated for 1,600 puffs, as they say. And I thought that'll be interesting to open up and see the construction inside and what size of battery it uses and if it's rechargeable. Spoiler, it is rechargeable. And when I actually took out the packet, the first one I bought, this is the second one, was this, it was a yellow one, sort of like a pastel yellow, like old 1960s laundromat machines. And when I took it out the box, it was in a sort of sealed plastic package, and it was full of liquid at the bottom. And I was thinking, oh no, that's probably gone through all the electronics. And how did it get out in the first place? It must have leaked from the tank. And I gave it a puff to see if it worked and got banana flavour, but no action. So I thought, well, I could take it back to the shop, or I could just take it to the bench and take it apart. And what I found was really interesting, because initially I was thinking, this is what's inside it. I was thinking, what has gone wrong here? That's because this is a wicking material. It's not like a pure liquid tank. And I was trying to work out how the liquid had somehow got out of that. It turns out it got out by vaporizing in the packet. The unit was actually triggering the packet. And the reason for that is because at some point, liquid has contaminated the little sensor at the bottom here. And I can show you that because I managed to catch it in video, so I'll show you that now. So the unit is now misbehaving. It's flickering the output to the heat element. And one of two things will happen. It will either just clear itself and then it'll fade back out again, but it would be running the heat element at low power at the moment. I don't know why it's doing this. It's gone up to full power. It'll either clear, or after a certain time delay, it will go into a sort of standby mode if the puff duration is exceeded, and it flashes LED. So it's done that, but then it will re-trigger itself. So this is the problem. Watch your eyes, the light is coming back. The light is back, and I've also taken this module apart, so let's explore it. I shall zoom down on here so we can see it in greater detail. The little sensor consists of a metal shell. It looks a bit like a microphone, an electret microphone, but in reality it's just a ground metal shell, and it's got a physical membrane sensor in it to detect pressure differential. The circuit board in the bottom has a chip and a little decoupling capacitor on the inside of it. Signs of corrosion around here. This is a clue as to what's going on here. And there's also a metal ring round the outside. On the back of it are the 3-wire connections and an LED, just for the sort of like the I am active and status type sort of modes. So sitting on this metal ring here, which is a sensor ring, is a little metal cylinder with a metallized film on top. And if you look inside the outer metal sleeve here, which is grounded, then there's a plastic separator here on the outside, and then there's a little red washer here that keeps this membrane away from the metal front. When you draw air, a pressure differential, air is drawn in through these little vent holes, and it pulls that diaphragm up until it touches that, and that effectively connects that gold centering to the sense input pin. It's connected to the sense input pin. It connects it to the sort of the general ground via the contact to the membrane with that. That then turns on the LED. It also turns on the heater, which is this little coil here, sat down into this slot in a sort of fiberglass sleeve. And that would normally have a little cotton wick through it. The cotton wick is gone. I've never seen that before. It's literally finished the liquid that it could get, and then it's burnt the cotton wick away. So quite a lot's been going on in there. This other sleeve is for sliding down. It's a slightly bigger sleeve. You close this up and then it slides down to lock it in place. I shall show you the inside of that membrane thing. I've taken the little chip out. I shall zoom down a little bit more because it's even smaller. So here is the chip, which is an SY312640. That did not come up with anything in Google. There's the tiny little capacitor that was across it. It's microscopic. So here's the circuit board, the outer grounded metal shell. There's the plastic spacer that at the side, the metal tube that goes up with the membrane across the top, and then there's a space that keeps it away from the front. When you pull a pressure differential, and there are a couple of little vent holes through here that let air sort of circulate in and out just to give equalization of pressure. When a pressure differential is detected in that direction, it effectively just domes that up until it touches that, and that then signals to the chip that a puff of air has been taken. Interestingly, I thought, because it was wet, I thought liquid had bridged up to the membrane to the outer shell, and that was a problem, but it's not, because I took the circuit board, I took the whole thing apart, but then I reconnected again saying that'll be the fault clear. No, it wasn't. It was triggering again. And it turns out that there was flux and schmoo all over this. I think it was just connections bridging, possibly e-liquid getting in onto the circuit board and actually bridging the pins. But the chip itself is very simple. It's got that little capacitor across it. It's got positive, negative. It's got the sense input that just gets effectively grounded to the negative rail. And then it's got the LED output with current limiting, and then the heater output, which does not have so much current limiting, and they're controlled by, well, just a dedicated chip, a chip that seems to have been around a long time. On the other side, we've just got the 3 wires tacked on and the LED. It's very interesting, a very intriguing way it's failed. I've just poured that little chip off. So let's take a look inside this. It comes with the plastic sleeve on either end, and if I just smack it off my hand, because I have already broken the glue seal, here's the construction. We have the double pin. We've got a little absorbent mat for absorbing any spillage, which I thought that was odd. It's definitely come out as vapour from the other unit. It's got the wicking material with the heating element, and it's got a lithium rechargeable battery in it, rated 850 milliamp hour. And I have tested this. It took a charge, no problem. NPS 17350, so 17mm diameter, I presume, and 35mm long. Let's use the calipers to check that. Roughly 17mm diameter, yes, and about 35mm long, yes, good enough. And the little integrated circuit. This is normally taped in with sort of sellotape wrapped around the outside. But the little integrated circuit, well, the little control module is just tacked in with glue just down the base there, and that's what does all the sensing and powers up these pins. Interesting. Very similar to the Geek Bar type device. Very modular. Such a waste. You use it. The lithium cell is rechargeable, but you use it until it's run out of juice or power, and then you bin it. That's not great, is it? But interesting construction. If you wish, you can refill it and recharge it. You can't recharge it via these pins, which is a shame. Some of them you can, because the chip is the standard chip used in the rechargeable types. But you can basically hotwire onto the battery if you wish, and with a suitable current limited supply capped at 4.2 volts. As for this, you can basically just, well, either to refill this, it's probably easier just to take the silicone thing out the end and just squirt drops of your favourite nicotine, so I've said that word, or not, liquid down the side so it soaks in, and that would be it refilled if you wanted to do that, if you wanted to be ecologically minded and recycle it, or better still, just get yourself a proper one that is designed to be refilled easily. But it's interesting, certainly. This one is notable, unlike some of the, well, this one, for instance. This one contains benzoic acid. The tobacco industry is doing that a lot. They call it nic salts. In reality, they're adding a bit of acid to it to increase its that stuff, that drug stuff that people take. It's so hard not to say it when you're talking about things like this. YouTube does not like that. It'll probably demonetize the video anyway. But this one actually in the ingredients didn't list that, and when I tried it, there was no sensation, that biting sensation you get from the more aggressive substances, although it claimed to have the same sort of level of the plant extract. But that's it. That is interesting. I've never seen it feel like that before, where one has basically emptied itself, re-triggering inside the package. And it makes me wonder how many in that box had done that. But it's kind of fascinating that these things can go wrong. And it makes me wonder what risk was there of it going on fire. It kind of burnt clear, but there was still some liquid left in here that probably absorbed some of that effect and stopped it going any further. But there we go. interesting, very unusual failure.